Okay, let's start Chapter 6. Chapter 6 is about solving systems of equations and inequalities. In 6-1, it's all about solving systems by graphing. So what do I mean by systems? We're going to start with a few definitions. And please take notes during this video, bring them to class tomorrow, and then it'll help you do all the questions in class. A system of linear equations is a set of two or more linear equations containing two or more variables. So what I mean by that, in a system it starts with this symbol, which I know some of you don't enjoy doing. There is no end. It's just a starting one. You might have an equation like y equals 2x plus 4, and a second equation like y equals negative 1/2 x minus 5. For example, these equations together, each one has two variables, x and y, and there's two of them. Together, they make the system of linear equations. The solution of a system, because we have to do something with them, we're going to find the solution of them. And the solution is an ordered pair that make both equations true. So using the equations, we will be finding an ordered pair, and that ordered pair is a solution. Here's an example, example 1a. My ordered pair is 1, 3. Okay, it's written as an ordered pair with a semicolon and then the system. This system is 2x plus y equals 5, and negative 2x plus y equals 1. I'm going to plug in my 1, 3 into both equations. If it's true for both of them, then 1, 3 is a solution. So 2 times x, which is 1, plus y, which is 3, does it equal 5? Okay, 2 plus 3 does equal 5. So it's true for the first equation. Okay, and I'll put a little check mark so that I can see it easily. I still need to do the second one. Negative 2 times 1 plus 3, does it equal 1? Negative 2 times 1 is a negative 2, plus 3, does it equal 1? And negative 2 plus 3 does equal 1. Both equations are true with 1, 3. That means 1, 3 is a solution. And your book says yes. Yes, 1, 3 is a solution for this system. Let's look at example B. My ordered pair is 2, negative 1, and my system is x minus 2y equals 4, and 3x plus y equals 6. Let's plug in x, which is 2, minus 2 times, 2 times a negative 1, okay, does it equal 4? 2 minus 2 times negative 1 is positive 2, and 2 plus 2, does equal 4. So that's true. Let's do the other one. 3 times 2 plus a negative 1, does it equal 6? 3 times 2 is 6, plus negative 1 is like minus 1. And that's 5. That does not equal 6. So the answer is no. Okay, 2, negative 1 is not a solution for the system. That's the first example. The second example is about actually graphing them. On a graph, the solution to the system, if I have this, and I have one equation line here, and the second one here, the solution is right there. Okay, it's the intersection. The intersection on the graph is the solution. What's great about graphing, or when it's already graphed for you, is that it's easy to see it. It's not the best way we're going to learn how to solve systems, because graphing, it can't be perfect for every equation. So we'll be practicing it where it works out well, and then we'll move on and learn some other ways to do it too. So let's look at the first one, example 2a. We're going to solve by graphing. And let's get our grid. Okay, for my first equation, y equals x, My slope is a 1, right, because there's a 1 right here. And my y-intercept is 0. It's not even in the equation. So I'm going to start at the origin, 0, 0. And my slope is a 1, so I'm going to go up 1 over 1. Let's change colors. Oops. Okay, so that's my first equation. My second equation has a slope of a -2 and a y-intercept of -3. So I'm going to go down 3, 1, 2, 3, oops. And I'm going to go a -2 over 1. Oops, that's a little off. Let's try again. Wow, this is really hard to do on the iPad. Holy moly. Okay, that's pretty good. I think you can tell where it's supposed to be. The intersection is the solution, and that is the intersection. So that means my solution is a -1, -1. It's good to check. So let's check with -1, -1. For y equals x, that's true, that works. For the other equation, -1, does it equal a -2 times -1 minus 3? -2 times -1 is +2, and 2 minus 3 is a -1. So it is true for both equations. My solution is -1, -1. Let's look at example B. My solution is my system, is y equals 1/3 x minus 3. My second equation is 2x plus y equals 4. My slope is 1/3. My y-intercept is -3. My second equation is not in slope-intercept form, so I need to move this 2x to the other side. And I get y equals -2x plus 4. Now it's in slope-intercept form. My slope is -2, and my y-intercept is 4. Let's make, oops. Okay. So let's start with the first one, 0, -3. I'm going to go start at 0 and go down 3. And my slope is 1, 3, so I'm going to go up 1 over 3, 1, 2, 3. Let's graph that line. Oh my goodness. There, that's pretty good. Okay. My second equation has a y-intercept of 0, 4, so let's go start at 0 and go up 4, 1, 2, 3, 4. My slope is -2 or -2 over 1, so I'm going to go down 2 from here, 1, 2, and over 1. Okay, that's pretty good. So my solution is the intersection, and the intersection looks like it's right there, and that would be the point 2, -2. If I checked it, I would get, sorry, that is definitely not 2. I go over 3, 1, 2, 3. That's at 3, -2. If I checked it, if I plugged it in the equations, I would get that it's valid, that it's true for both of them. So my solution to the system is 3, -2. Alright, good job everyone, and have fun in class tomorrow practicing these questions, and then have a great weekend. I'll see you all on Monday. Bye everyone.